Hello everyone! Today we continue with our topic on profit maximization. At the previous lecture, we've learned different formulas for revenue, for total revenue as a product of price and quantity, for average revenue, and we've learned that average revenue is in fact just the price of the product, and marginal revenue, which shows how total revenue changes when we increase output by 1 unit. We've learned how average revenue and marginal revenue curves look like, and we've discovered that because average revenue is simply the price, it can be represented by the demand curve, because demand curve simply tells us what price consumers will pay for each and every possible quantity. So for example, when quantity is equal to 5, consumers will pay a price of 4. This will represent the average revenue for the company for this particular level of output. And marginal revenue is a line which is steeper than our demand curve. Both marginal revenue and demand curve will originate from the same point, but marginal revenue is steeper. And we've also learned that marginal revenue will cross horizontal axis because it can become negative. For some levels of output, along inelastic part of the demand curve, further increases in quantity will lead to reduction in total revenue, as shown in this table, which will imply that marginal revenue will be negative. In other words, marginal revenue is a line which crosses horizontal axis. This is what we've covered previously. We've also spent quite a lot of time at the previous lecture explaining the shape for the total revenue curve. We've learned that it originates at 0. When we don't sell any output, total revenue is 0. Then it goes up and reaches its maximum. Total revenue will start to decline. So it does not necessarily mean that you need to produce maximum level of output to maximize your revenue. There will be some point on the total revenue line, some level of output where total revenue is maximized. If you exceed your output, if you produce beyond this point, total revenue will start to decline. We've also learned the formula for profit. We've learned that profit is the difference between total revenue and total costs. So using totals, you can calculate profit as simply the difference between these two. And this was our first method of finding the profit on a graph by comparing total revenue and total cost curves. However, there is another formula which you can use as well, which tells you that the profit can be calculated as profit per unit, difference between price and average cost per unit. How much you make per each unit times number of units times quantity. And we are going to illustrate this formula on a graph today. So we'll try to find the best profit maximizing level of output using this type of the formula. This is what we'll do today. Previously, we've also learned the difference between normal and abnormal or supernormal profit. And I've explained to you that in economics, in any economics textbook, when we'll talk about profit, we'll always talk about abnormal or supernormal profit. In other words, what you try to earn above the normal profit. In economics, we assume that normal profit is made regardless, because if you don't make the normal profit, the business should be shut down. So strictly speaking, we assume normal profit as part of our costs. We'll need to cover this together with all other costs of production in order to make business worthwhile. This is what we've studied previously in the previous lecture. And we also learned how to maximize profit, how to find profit maximizing level of output using total revenue and total cost curves. And we've discovered that if we combine total revenue curve shown by this blue line and total cost curve shown by a red line, we will be able to identify the profitable range of output, which will be between points A and B. So you must be producing somewhere within this area, this level of output, in order to make a profit, because within this range of output, your revenue will exceed your total cost and you will be making some profit within this area. And the total profit curve will look like this green line. It will start at negative area. So in other words, when you start your business, you will be making losses because your costs, red line, is higher than your revenue, blue line. Then you will reach a point where these two curves cross. In other words, you will reach your first break-even point. This is the point where you don't make any profit or any loss. Your costs are just equal to your revenue. Then your profit increases, reach the point where the vertical distance between costs and revenue is maximized. This will be your optimum level of output, and then profit starts to decline. So this is what we've studied previously. And we've also learned that your profit profit can be shown as this vertical gap, the biggest possible gap between total revenue and total cost. Your optimum production level in this particular example would be 3 units of output. This will allow you to make maximum profit of £4. And we've ended our session with the profit maximization condition. We've learned that in order to maximize the profit, firm must select a level of output so that marginal revenue is exactly equal to marginal cost. This is the only level of output which will allow you to maximize your profit. And I've explained that when marginal revenue is not equal to marginal cost, when it's greater or lower than marginal cost, you can adjust your level of output and increase your profitability. You can reduce your quantity or increase your quantity, and your profit will go up. And there is only one point where your profit is maximized, and this is the point where marginal revenue is equal to marginal cost. There is nothing you can do to improve it. This is your very best position to be in. And we've also learned that this condition, profit maximization condition, holds in the long run as well. So long run marginal revenue should be equal to long run marginal cost to maximize your profit. And this condition also applies to firms working in various market structures. We went through a graph which looked like this. So the first graph showed us our maximum profit as a gap between total revenue and total cost. But today we will focus on the lowest part of the graph, which focuses on this profit maximization rule. It tells us how exactly we must identify most profitable level of output, 30 units in this particular case, as a point where marginal revenue equals to marginal cost. This will be the subject of today's lecture.